In this lesson, I'll show you two examples on how to find the domain of a function of n variables, and then I'll show you how to write the domain in set builder notation. The question reads, find the domain of f of x, y, and z for the function sine x plus y over z minus 1 plus ln x plus y squared. To find the domain of this complex function, we have to go term by term. Let's start with sine x. If you input anything into this x as an angle, you'll come out with an output. Therefore, there are no restrictions for sine. Next, we have y over z minus 1. The only issue with fractions is that the denominator cannot equal to 0. You can't divide something by 0. So what we say is z minus 1 cannot equal to 0. Solving for z, we end up with z cannot equal to positive 1. That's the only restriction for this term. And finally, for our last term, we have ln x plus y to the power of 2. The only restriction for ln is that this part needs to be greater than 0. So we'll set x plus y to the power of 2 must be greater than 0. You don't need to solve for x or y here. You can just leave it like that. Now, to write this in set builder notation, we will say that the domain includes the set of all x, y, and z variables such that x, y, and z include only real numbers, and then you write down your restrictions, the ones that you found, where z cannot equal to 1 and x plus y squared must be greater than 0. Let's move on to question number 2. Find the domain of x sub 1, x sub 2, x sub 3, x sub 4 for the function that you see to its right. Once again, we have a fraction here, and just like in question number 1, the denominator, x to the power of 3 minus x to the power of 4, must not equal to 0. So if I rearrange these variables where I have x sub 3, it cannot equal to x sub 4. That's the restriction for this. And the restriction here, e is raised to a radical, a square root. And we know that with square roots, if we're dealing with real numbers, this part, the radicand, needs to be greater or equal to 0. So we'll set x sub 1 plus x sub 3 must be greater or equal to 0. If you'd like, you can even bring x sub 3 to the other side just to make it look neater. Therefore, x sub 1 must be greater or equal to negative x sub 3. It's up to you if you want to represent it this way. Most students will stop at this point. Now, to write this in set builder notation, we say the domain includes x sub 1, x sub 2, x sub 3, x sub 4, such that these variables include real numbers and then our restrictions, which were x sub 3 cannot equal to x sub 4 and x sub 1 plus x sub 3 must be greater or equal to 0. That represents the answer to question number 2, and that is how to find the domain of a function of n variables.